Okay, number 11. Let's start with substituting first. So negative 1 squared is positive 1. Negative 1 times negative 3 is positive 3. And then minus 4, we have 0 in the numerator. 4 times negative 1 squared is positive 4. Plus negative 1 and then minus 3. Okay, denominator is now 0 as well. So again, indeterminate, I need to get rid of that. So factoring is one way. So let's just factor here. So we would say limit as r goes to negative 1. And then on top, I have r. So two numbers that multiplies to negative 4 and adds up to negative 3. I put a comprehensive review of factoring in chapter 1 modules. If that's a challenge, I suggest that you go and watch those videos. So that would be r and r, two numbers that multiplies to negative 4 and add up to negative 3. So that would be negative 4, positive 1, r minus 4, r plus 1. And then to factor the denominator, so you would say 4r squared plus r minus 3. I'm going to show you with the AC method that you also see on the videos under module 1. So you multiply, because something is other than 1 is multiplied by r squared, you multiply the first and last term, that's negative 12, and the middle term is 1. So two numbers that they multiply to negative 12 and add up to positive 1. So that's 4 and negative 3. You break the middle term with these two numbers that you found. So that's 4r minus 3r. So instead of r, I write it as 4r minus 3r by these two numbers. I bring the last number down. I bring the first number down. So let's factor from here. So 2 by 2, you factor 4r from the first two, so it's r plus 1. And then factoring negative 3 from here, r plus 1. And then r plus 1, common between both, and I have 4r minus 3. So my factors here are r plus 1, and then 4r minus 3. The only thing that cancels here is r plus 1 and r plus 1. I'm going to erase the factoring process to give myself a space. Again, you have it in the recording. Even if it's not going to be on the picture for now. On the test, do not erase things. I need to see the process of your thinking. So replace r by negative 1. So on top you have negative 5. R on the bottom. So it's 4 times negative 1 is negative 4 minus 3 is negative 7. Negative and negative cancel. So the answer is 5 over 7. Okay. Next. Limit as x goes to infinity. On top, so when you are finding limits as x goes to infinity, you can always think about it this way. If you substitute, first of all, infinity here, a large number minus 9 is a very huge number. Square root of that is huge, so it's infinity. And then 2 times a huge number is huge, and then minus 6 is huge, so it's another infinity. So infinity over infinity, like 0 over 0, is indeterminate. You need to get rid of that. So in order to simplify limits as x goes to infinity, There are multiple ways of thinking about it, but one is when you have power function like x squared, 2x, x cubed, use the leading term of the top over the leading term of the bottom. So the leading term of the top is radical x squared. The leading term of the bottom is 2x. So radical x squared over 2x. So that is equal to limit as x goes to infinity, and then radical x squared comes out of radical with absolute value. These two are equivalent over 2x. But knowing that x is approaching positive numbers, so I can just remove the absolute value and have it as a limit as x goes to positive infinity, and instead of absolute value of x, I just put x over 2x. And that is equal to x and x cancels. You would have a placeholder of 1, so it's 1/2. So 1 over 2. Okay. The next one, number 15, limit as x goes to pi a little bit less of ln of sine of x. Okay, sine, let's just do the substitution here. So sine of pi a little bit less. So limit, but let me just replace it. I would have ln of sine of x, but now x is pi a little bit less. Okay. Let's see, what is that equal to? Sine of pi a little bit less. So if you think of the unit circle, sine of pi itself is 0, but then approaching that from a little bit less than pi, it's going to be here. So sine is positive there. That's one way to think about it. Or if you think about the graph, think about 2 pi, and then think about pi, and then as you know, the graph goes up and then goes down a little bit before pi, so that would be here. And again, as you see, that's corresponding to positive 0 a little bit more. Inside ln is always a positive number, so if this was a negative number, then it didn't exist in the root, in the domain. So now ln of 0 a little bit more. If you think of the graph of ln, it's this way. 0 a little bit more. So if you go the inputs that are very, very close to 0, the output is very, very close to infinity, but negative. So the answer to this one is negative infinity. I'm going to erase this board so I have room for the next question. So next, replacing infinity. So it's going to be infinity plus 1, and then radical of that, a huge number plus a huge number plus 1. Square root of that is a huge number. Minus huge number. So huge minus huge is another indeterminate, like 0 over 0 or infinity over infinity. Because you don't know which infinity is larger when you're subtracting. So that's why indeterminate. You cannot really determine what that is. So in order to get rid of these type of indetermination, usually, not always, you multiply top and bottom by the conjugate of what you see. So you would have radical x squared plus 4x plus y, this time plus x, over, same thing at the bottom, x squared plus 4x plus 1 plus x. So we turn this minus to a plus. Okay, now I'm gonna give this one a denominator of 1. So let's multiply now. So we need to FOIL it. In order to FOIL, multiply the first one by first one. So imagine that this is like a parenthesis. First one by first one, then first one by the second. So for those two first by first, I just remove the radical. So that's x squared plus 4x plus 1. So by multiplying those two radical removes, multiplying the first by second, that would be positive x times radical x squared plus 4x plus 1. And then now negative x times radical. So that would be negative x radical x squared plus 4x plus 1. And then the last one is negative x times x is negative x squared. Radical x squared plus 4x plus 1 plus x. Limit as x goes to infinity. Okay, now let's see what cancels. As you see, these two cancels, and then x squared minus x squared cancels. Now let's replace the infinity. On top, I will have 4 times infinity plus 1 infinity. On the bottom, I would have infinity squared plus infinity plus another infinity. So this time, infinity plus infinity is another large number, is infinity for sure. So now you have indetermination of infinity over infinity. Basically, you started from infinity minus infinity, and now when you replace, you have the indetermination of infinity over infinity. So this one is easier to get rid of. What you do is you're gonna write limit as x goes to infinity of the leading term on top, that's 4x. The leading term on the bottom is basically radical x squared, which is absolute value of x, plus x. They are both degree 1, so you need to write both. You remove absolute value because it's positive infinity, so it's limit as x goes to infinity of 4x over 2x. And then here x and x cancels, 4 and 2 cancels, so you have 2 left. That's the answer. Okay. And the last one of this set, you have limit as x goes to 0 of tan inverse of 1 over x. So you would have 1 over x, 1 over infinity. So now you need to think if it's positive infinity or negative infinity. If it's over 1 over 0, a little bit more. So it's going to be over positive infinity. So here is what you can think about it. You have positive infinity. Now you are thinking of tan inverse of positive infinity. That's what you need to think and have in mind. So tan inverse of infinity. So if you think about positive infinity, the first infinity of tan is what? Cosine, sine over cosine, sine of x, or theta over cosine of theta. To be positive infinity means cosine is 0. And then so tan inverse of infinity is going to be pi over 2. The first place that you would get infinity is tan of pi over 2. So tan inverse of infinity is pi over 2. So here's what you know. You know that tan of pi over 2 is infinity. So tan inverse of infinity, which is this question, is equal to pi over 2. And so pi over 2 is the answer.